Now, talking much about Docker, I have a PPT. I can showcase that for you. What happened? Docker is an open source project. Okay. What's the difference between the Docker and this normal virtual machines are? Docker is something similar to virtual machines where you can host the applications. So what is the purpose of, when I say the purpose of the virtual machines and virtualization technology, everything is to host a single, to host an applications on the virtual machines and to serve it to the end users, right? Now, when we talk about the ongoing virtualization platform, here you can see you'll have the server. Above this server, you'll have the host operating system, or either it may be a type A or type B. If not, you'll have the directly virtualization. With the help of this virtualization technology hypervisor, what you'll do, you create the VMs. Again, every VM will have the guest operating system and the binaries, libraries, and the applications finally that serves to the client. Okay, on that application you'll have your code and that serves to the clients. Now, so here you can see the guest operating system, everything is, or something, again, these are utilizing the resources of your physical box, right? So we have a concept of Docker where you'll have the servers. On the server you'll have, anyhow you'll have the host operating system. Okay, the same host operating system kernels or binaries or libraries will be shared with different containers are something similar to VMs, not exactly, but to some extent. So on each and every container that you launch with the help of Docker, okay, you can host a single app onto the app instance application onto the Docker. Every container on the Docker is independent to each other. Okay, it's like, for example, on this guest operating system, on this VM you can install only one VLC player at a time, or one Apache at a time. You cannot install multiple Apaches on the same machine, right? But when it comes to this concept, container concept, on each and every container you can install Apache. Like that, you can maintain n number of containers with the same Apache application or MySQL database or whatever it is on the same server. And also here you don't need to worry about the guest operating system and everything. Okay, and the hypervisor kind of thing. It means that you are even saving the more resource of your physical box. That's the reason this industry drawn a lot of attention towards this Docker. Now, right now, most of the people are moving. They wanted to build, they wanted to design, they wanted to test, and they were finally they wanted to host their product on the Docker only. Okay, on the market you can find the Docker is it's going very far off graph. Now Docker supports all the platforms. It can be installed on your Linux machines, Windows, and Mac. Okay. Now for Windows, actually, what's on the backend Docker runs on only on Linux. So what happens when it comes to Windows Docker doesn't run. So what they are doing on the Windows, they are installing a small piece of package called Docker Toolbox. Okay. What exactly this Docker Toolbox does is it installs Oracle VirtualBox. Okay, and it will launch a VM with Linux operating system. On the Linux operating system, you'll have the Docker. This is how they are doing with this Docker toolbox. Okay, this is for specially Windows 7, 8, 10. Okay, now you know that again Oracle VirtualBox is an virtualization technology where you create VM. On that VM, they are installing the Linux operating system. But these guys have modified this Linux operating system. This is not something Linux operating system like CentOS or Red Hat or Ubuntu or something. They had their own operating system called boot to Docker. Under this operating system, you'll have a very basic Linux packages. Okay, this basic Linux packages supports only to run the Docker on that machine. Why they design this is their intention is to design a lightweight operating system where they can run the Docker on that. This is how they are doing with the especially when I talk about Windows 7, 8 and 10. But when it comes to Windows 10 or Windows 10 Pro Plus or Windows Server 2016, okay, on these two versions, Windows has already native hypervisor technology. Means hypervisor technology is installed natively with operating system on this. By using that hypervisor technology, they are directly launching this Ubuntu Docker VM, not require this Oracle VirtualBox. This is how they are running this Docker on this Windows. That's the reason I told you. Microsoft integrates Docker with Windows Server 2016 and desktop version 10 Plus Pro because Microsoft, along with the operating system, he is also installing Windows hypervisor, that is Hyper-V. Okay, there is a virtualization technology designed by Windows. But when it comes to Windows 7, there is no Windows hypervisor. That's the reason they are using Oracle VirtualBox hypervisor to launch this boot to Docker bootable VM so that they can run the Docker on that. But when it comes to other operating systems, Ubuntu, Fedora, or HCL CentOS, they can directly install this Docker on that Linux machine. Now, talking about Docker much, Docker consists of, when I say Docker, Docker is a platform where you can run the containers actually. On each and every container, you'll have the applications. Okay, here each container will share the basic operating system's kernel. Okay, when it comes to the old legacy virtualization technology, here it creates a virtualization, a guest operating system, and it will virtualize even the kernel also. But here it uses the native operating system kernel, and every container is a combination of images. When I say container, okay, each container is a combination of different images, okay, that are layered upon each other. So example, I want to build HTTP. I need an HTTP server, web server. So what Docker does is first it will create an image with base operating system. Okay. And second, it means that it will add a layer to your container. Second, it will add a package, something that is prerequisites to HTTPD, and then HTTPD. So this is how the container is a combination of different layers. Each layer is an you, you can assume something like base operating system or package or whatever it is. So base image forms one container. Now talking about container architecture, see Docker architecture. Docker will have mainly three components. One is Docker server, and the other is Docker daemon, and the other is Docker client. So when you install Docker on any operating system or machine, what it does, Linux, usually you'll install Docker on Linux, I told you. So if you run any package on Linux, so what it happens on the backend, it creates a daemon for that. Similarly here, for running the Docker, it creates a daemon. Daemon is the something actually that does the real work. Okay, and Docker client is an command line tool, an interactive platform between the Docker daemon and the user. Okay, on the command line tool, you'll enter all the commands so that this Docker client will parse that user commands to the Docker daemon. So Docker client will act as a broker or intermediator between the user and the Docker daemon. Now, when I execute a command like, hey, Docker create container on the Docker client, no, Docker client will parse that command to the Docker server. No, actually, Docker does server does the creation of that container. And coming to Docker Hub, now why this Docker has become much famous is there is one more advantage. Assume that you have a physical box and you have a Docker on that. Docker is installed along with your operating system, along with side of your operating system. Okay, now you have containers created. Assume that this is web container, this is app container, this is database container, or this is some X container. And this containers is using by some people. This is using by developer. Assume that one developer is using this container and he's writing all the code and he's storing the code on this web container and he's testing it and he's seeing the output. Now what happens, my project manager says, after developer writing everything, he'll approach the project manager and he say, hey, I have done writing all the code that according to your requirement. Now project manager wants to test that code, right? How the developer writes. So he'll call the tester. Now tester what usually do on the olden days, legacy days, what happened? Again, they built a new container, they copy the code, okay, and they'll host the code on this container. This is what happening on the legacy. But here, when it comes to Docker container technology, you can export the entire container. Okay, you can export the entire container to a mediator server called Docker Hub. Okay, and the tester can import that entire container. Okay, and he can test that. It means that whatever the work did by developer on the container, as it is, he's exporting along with entire operating system, application, and the source code on the application, everything he's bundling and he's shifting that to the tester will test it and again he'll export that as an to different pre-production and finally it goes to production. It means that the same container where developer tester everything worked and they approved that gonna go to the production. Here not we are not creating any environment or nothing. We are just copying it and we are deploying. That's the reason there is an saying that became famous with this Docker. As I told you here on the first slide, you can see that Docker, any container you can build, you can ship, and you can run on any. other Docker machine, whoever as it is. Okay, that's the reason here you can see on the logo that Docker, they have designed their Docker logo this as a ship, okay, whale ship, where they have all the containers. Assume that containers is something like the on the port you'll have the containers, right? On shipyard port, what you do if I want to move something from my home, what I do, I'll pack that and I'll load that into an auto and then into a truck and then into an shipyard port and then into shipyard container. This is how I'll export. Similarly, assume that your code will be packed as a package into the container and the container gonna reach the destination either by a truck or either by a ship or either by a plane, whatever it is. Okay, but whatever the inside the container, that's gonna be same. Okay, that's the reason this logo is something similar to that. You build it with the help of Docker daemon, you make as a container, and you can ship that container to any other Docker installed machines. That's the beauty of this Docker. That's the reason most of the people wanted to addict to Docker. I mean, they wanted to use this Docker technology for building their application or testing or hosting or whatever it is. Now, coming to Docker technology, I told you containers, containers, containers. So on the containers, you'll launch the applications, and the container is made up of images. Now, what exactly these images mean? Talking much about, I told you images are nothing but something prerequisite is assume you can assume that as a package or something. So what happens in real? You'll have your operating system. Assume that this is your physical box. On that, you had a Docker. On that, you have two containers, container 1 and container 2. So as soon as you install the Docker on your physical box, okay, the Docker does not create the containers. The Docker will have Docker daemon, Docker client, and local registry. When I say registry or repository is same, where you store all the Docker images. Okay. Now assume that you have the Docker daemon running on your machine, and you have Docker client, and you have local registry where you store all the Docker files. Now from the client, okay, the person will interact to the client, Docker client, and he will run a command like, hey Docker, run any application like httpd, means Apache. First, this Docker client will pass this command to Docker daemon. Now Docker daemon will check whether this HTTP, for running this HTTPD, Docker daemon requires this HTTPD images, right? Now it will check in the local registry whether the HTTPD image is available or not. If available, it will create one container and it will launch that it will load this image into the container, and it will launch the container. Okay, if the image is available, the Docker daemon will load the image into the container, and the container will be on up and running. If not, okay, now this Docker daemon will communicate with Docker Hub. What exactly this Docker Hub means? Docker Hubs are public and private repositories that are maintained by Docker organization. It's similar to GitHub. Okay, GitHub is hosted with Git Cloud, their servers, but you're using it. Similarly, Docker Hub is maintained by Docker guys, where you'll have the repositories. On the repositories, you'll do everything. Guys, just 1 second. Now, where are we? Okay. Talking about Docker Hub. Docker Hubs are private and public repositories that are maintained by Docker guys. Let me show you. If you open Docker Hub, this is a website or the repository site that is maintained by Docker guys. For it, you need to create, sign in, something, choose Docker ID. I can choose something Docker ID. I have my Docker ID. I don't know the password. I think I have forgotten it. Let me try. Okay, sign in, right? Okay. Forgot password. Email ID. I don't know what I have given. I think I have given my office email ID. Okay. No problem. Docker Hub UI. After login, you will get an page, something like this. Under this, excuse me, you can create repositories. Okay, and you can make the repository as an public or private. If you make the repository as a public, so whatever the images that are under this repository, those can be seen by everyone, whoever has that image link. Okay, if you make it private only, you can communicate with Docker. You can see that. Now when I want to, let's see, assume that now this Docker daemon, it doesn't found, it will download that from the Docker Hub and it will create a container. Now what I do after creating a container, now developer will start writing something new on that piece of code, HTTPD. He'll put your product and he'll test it, and again this developer, he will create another image from this container. From this container, he will create an image, a new image. Okay, and this new image, he did some work right on this container. Now he saved it as a new image. Now this new image gonna, he has to share it with the tester. So what he'll do, again he'll upload the same thing to Docker Hub. Now with a image name with tag like latest. For every name, the same name, he'll add tags. Okay, now that latest, whatever the tag he added for that same image name, is gonna be given to this colleague tester. So the tester will download that, again he'll launch it in his machine. This is how the Docker can be easily bundled and can be shipped and can be downloaded, and it can be moved across different platforms. So any doubts on this topic, guys?
No, Karthik.
Okay, now talking much about this, now again I told you containers are a combination of images. In real, even the images are combination of layers. Okay, layers instance, if you talk about that might be a one package of Linux or something. Okay, now one way to deal with Docker is either through Docker client. From the Docker client, you run the command and you tell the Docker daemon to perform something. So the Docker daemon will do that launching of Dockers and containers and everything. The other way is you can use Docker file. Whatever you wanted to do, write everything on the Docker file, okay, and parse that Docker file to your Docker daemon. So the Docker daemon will read all the steps that you have written in the Docker file, and it will does the same thing. So one way is you can interact with the Docker daemon from the Docker client by directly writing the commands. The second is you can write all whatever you require into one single file called Docker file, and you can run the Docker file. Okay. Now that's what this small architecture defined. Not only from the Docker CLI, you can write it from the Docker file, and you can tell to Docker agent. So Docker agent will talk with Docker daemon, and it will launch. It will build an image, and other people can test the same image, and they can push the same image to Docker registry. From that, it can pull to that production, and it can be served to the live customers, and it can scale. Now, when I talk about scale, for doing the scaling and everything, we have a concept called Kubernetes. Okay, there are some limitations with Docker. One thing is on the physical box, you are running different containers, right? Now, assume that I have a container with Apache and my customers have started using that container. Now, certain point of time, it can handle to some level of extent of bandwidth, not all the traffic. Now, my customers started growing. Okay, now container, guys, container will not have any restricted uh, resource capacity. Like you cannot restrict, I mean, if you want you can restrict also, like with 2 GB RAM, okay, 30 GB volume, like this you cannot restrict. It dynamically pulls the available resource from this your physical box. Okay, now assume that this container is fully utilizing and more people are coming. So what you can do, the other way is you can launch one more container, and you can divide the traffic to that by using elastic load balancer, how we talk about in our auto scaling group. Here for doing all this high availability, elastic load balancer, scaling, this cannot be done with the Docker. For doing it, we have a separate concept called Kubernetes. Okay, Kubernetes is an orchestration tool. That's the reason I say the word orchestration tool for the Docker containers. Orchestration means the platform that handles everything, that monitors the Dockers, containers, load, high availability, I mean the load balancing. Okay, that's the reason we say it as an orchestration tool. Now, talking much about this orchestration tool, Kubernetes. So this is something like how do you install Docker? Okay, just if you're having some system, like you can type a command like yum install Docker. If it is a Debian based system, Ubuntu, type a command like apt-get install Docker. If you want to check the version of the Docker, just type the command Docker version. It will give the output of the client version. On the backend, Docker runs with Go programming language, Go. On the backend, Docker uses Git for storing. When I say the local registry of the Docker, it means that it is using Git as a backend to store all the Docker images. Okay, that's the reason Git. Now, guys, I wanted to make clear Docker client and Docker server. If you have different versions, major versions change, they cannot run. Okay, always make sure that Docker client and Docker server should have the same version. Some people, what they do, they does not install the Docker as a single bundle with Docker client, Docker version. Some install like they'll download the package Docker client and they install. Some people download the package Docker server and they install. In that scenario, make sure that both these are same version. No, actually, this container concepts, Docker concept was designed by Google. Okay, uh, the Kubernetes concept. On the back end, this Gmail, YouTube, everything will has hosted on containers only. Okay, Google has a software called Bragg, BRAG. So by using that Bragg software, okay, Bragg is an orchestration tool for containers. They are handling all this YouTube, Gmail, all the Google products. Now, from the Bragg, Google has developed the Kubernetes, and he handed over the Kubernetes project to a organization called CNCIF. Okay, now that organization is handling the Kubernetes project. Like if you want to run some container, just specify Docker, run the container name. BusyBox is a small container. When you parse that container, it will execute a command like hello world. If you want to run only you guys, it's even you can download a container with only operating system like Ubuntu. Here Docker run Ubuntu means it will download the container Ubuntu and it will run that container. Sorry, it will download the image Ubuntu and it will load that image into the container and it will run the container. And every container and every image Docker daemon will provide a unique ID for them. Okay. Now this -i and -t means interactive terminal. If you want to take an interactive terminal of that container, it means that if you want to interact with the container Ubuntu, you have to SSH and you have to do some commands, right? For that you have to type this -i -t and you have to call the bash. Bash is a platform where you run all the commands, bash commands. Now when you type this, the above line command docker run -i-t ubuntu bash, it will it will launch a container ubuntu and it will give you a terminal session. It will log in as a root account onto that container 04c0bb. That is an unique ID given by Docker daemon for that container. It means that you are connected to this container, you're logged into the container with the user root, and he has given you a bash terminal where you can run all the Linux commands. Like this, these are some commands. So what I'll do for you guys, I will give you a beautiful document I had with me. Just go through the document that describes in detail about the commands and everything. Why am I unable to download anything? I don't understand. Okay, I'll WhatsApp these slides to you. Just go to that. Now, talking about Kubernetes, I told you Kubernetes is an orchestration tool that was designed by Google and it was given to an organization called CNCIF. Okay. Now there are some points that we need to discuss about Kubernetes. One is Kubernetes is an open source project. No need to pay any amount. Just you can download it and you can run it on your local platform or anywhere. Now by using Kubernetes, you can manage containers across cluster of nodes. When I say node, consider each node as a physical box or physical machine. Assume that you have 10 physical machines. What you can do, you can create a cluster on the above the 10 physical machines, and you can run the Dockers on the cluster. I mean the containers on the cluster. If one node goes down, automatically Kubernetes will move that containers, whatever running on that node, to other containers, other node. Like, okay, I'll draw a diagram for you for better understanding of what I'm saying. Assume that you have physical box 1, physical box 2, and physical box 3. This Kubernetes concept will create a cluster on that physical boxes. I mean these nodes, node 1, node 2, node 3. And you will run the containers on this cluster. Now what if this node 1 goes down? This Kubernetes will always monitor the nodes. If it goes down, this Kubernetes will launch this move these containers from this to different workloads, machines, nodes. This is how it maintains the cluster as a mediator to move the containers from one node to other node if something happens with that node. It means that Kubernetes will always monitor the nodes. Kubernetes will always monitor the containers. If there is a problem with container, okay, it will recreate one more container from that image from which this container is created. This is how it maintains a high availability. If container has some problem, it will create one more container automatically. It means that Kubernetes can manage, monitor, and maintain the containers and clusters. Now, there are something to say. Kubernetes is lean, portable, extensible, self-healing. Self-healing, I told you, right? And it is extensible, and it is portable, very portable in installations and these packages. Now, Kubernetes will have a master and minion components. When I say minions and master, minions are like slaves to the master. So here on one machine you'll have the Kubernetes master, and all the machines are like slaves to that machine. These nodes, these are called minions. Okay, all these minions are connected to master. Now master will monitor and he will take care of all the minions that are connected to, that are under his category. Now with Kubernetes you can easily deploy, update, and scale the containers. Now Kubernetes, we can call it as K8 because that consists of 8 letters. Okay, and the logo is something like this. Is how the Kubernetes logo looks. It's like a ship. What it does, that steering, and it has 8 sticks. That's the reason they named it as Kubernetes K8s. Now, talking about in detail, Kubernetes has 5 components, 3 components and master, and 2 components in each and every node that you connect. When it comes to the components, every master component will have one API server, controller manager, and scheduler. What is this API server, controller manager, and scheduler? I tell you. I'll talk about one by one component. API server. API server, if you want to deal something with Kubernetes, if you want to tell Kubernetes, how do you tell the Kubernetes? For Docker, you have Docker client. Similarly here, you can interact with Kubernetes master with using the API, application programming interface. Okay, you have to parse the APIs to the Kubernetes master. For Docker, you have Docker client. Similarly, for Kubernetes, you have Kubernetes client, and we call that Kubernetes client as kubectl. I write it down for you. It's kubectl. Kubectl means kube controller. And not only this kube controller can parse these commands to this Kubernetes master. With the help of that, And the other best part of Kubernetes master is it manages all the nodes that are connected to it. That's the reason there is one component called controlled manager that manages all the minions that are connected to the master. And it run on schedulers. You can define some schedulers to that master so that according to the schedulers it does the activity jobs like creating the containers, scaling the containers, depending upon incoming traffic. Everything will be done with this Kubernetes master. And every minion node will have kubelet. Okay, kubelet. Okay, with the help of this kubelet, you can pass direct commands to the minions to launch containers on that minions, or you can directly pass the commands via Kubernetes master, so that it will pass the commands to the minions and it will launch the containers. Anything you can directly interact with minions, or you can interact via Kubernetes master to that minion nodes. This is how it looks. One way of interacting with Kubernetes is API. The other way of interacting with Kubernetes is UI, user interface. You'll have a very beautiful browser user interface where you can do all these activities, and either through command line CLI. You can interact with master, and master on the backend interacts with the nodes, and it will launch all the containers on the nodes. Okay. Now, if one container goes down, again it has to recreate one more container, right? For doing that, it needs some local registry storage where it stores all the images. That is the local registry. From the registry, it will pull the image, and it will load the image onto the container, and it will run that container on these nodes. Guys, are you catching me? Am I too fast, or is it clear to everyone what I am telling?
Yeah, clear, bro.
I have some knowledge on this, Karthik. So
Yeah, okay. What about others? Adi, Abhishek, Shankar, and Suraj. Abhishek, clear.
Yeah, it's clear, Karthik.
Yeah, it's clear from Suraj too. Okay. Hi guys, and remaining I'll assume that it is clear for you too. Now going further, and this is the PPT that I was designed in my office for giving a presentation to my colleagues. So you see all that my company logos on this PPT. Now talking about much master components, I told you that you'll have the API server, scheduler, and controller. Along with that, you'll have a small component called etcd. Etcd is a small database for your master. It stores all the information about the users and the activities, who is logging, the log files, everything. Okay. So all I can say is typically master consists of kube API server, kube scheduler, kube controller manager, etcd. Now your master will communicate with the minion nodes. For example, that minion nodes, on the minion nodes you need to have this Docker installed and this kubelet and this supervisor D. On that you create pods. When I say pod, what is this new word pod means? I tell you. On DevOps, creating different phases like environments, you call it as environments, right? Similarly, when it's come to Kubernetes, you call it as pods. Pods are nothing but environments. So on the environment, what you have different VMs, virtual machines or nodes. Similarly, here on the pods, you'll have many multiple containers. Combination of containers can form one pod. Assume that one pod has development pod, testing pod, QA pod, pre-production pod, and production pod. Okay, pods are nothing but similar to environments. Now with the help of this Kubernetes master, you not only can control the single container on the cluster of nodes, but you can control the entire pod. When I say what is the difference, you may ask, hey Karthik, what is the difference between controlling single container and pod? Assume that if I control pod, on my pod, assume that you have three containers. One is web server, application server, and database server. If something happens to the web server, now Kubernetes master will automatically launch a new web server, because it knows that in this pod there should always run 3 containers. One is web server, application server, and database server. This is how Kubernetes master keeps in that intelligence of the mind, or whatever it is. It always knows that. So how do you know Kubernetes all everything Kubernetes master? Because everything will be written in the file called YAML file, and you'll give that YAML file to your Kubernetes master. From that YAML file only it will create a pod, and it will always make sure that there should be at least 3 containers in the pod. One is web server, an API server, and database server. It all depends upon how you write, how you structure your pod, how you write it in a JSON format, YAML format to the Kubernetes master. We'll talk about that also in detail in next coming slides. Now, I want to talk about some keywords about this Kubernetes. One is master. We talked about it, that manages and maintains all the other minion nodes on the data center. One is other minions are that are slaves that are connected to the master, and pod is nothing but the environment where you combination of multiple containers you call it as pod. Now here you can see that a new word called replication controller. What does that replication controller means? Kubernetes master has a different feature, a new feature called replication controller. What this controller does is, if one container in the pod goes down, automatically it will launch a new container. So who is doing exactly that? Means a replication controller on your Kubernetes master. On the YAML file you have to specify that, hey, replication controller at least 2 web servers, means Kubernetes master will always see that on that pod it maintains at least 2 web containers. If one container goes down, automatically it will replicate with a new container. Okay, that means that replication controller. Now service. What exactly service means? Kubernetes will store all the passwords and the information, keys, everything with a name called service. And labels are nothing but the stickers, the tags that you give to the server side. Similarly here you can label your container, your pod, or anything, your cluster or anything. That are labels. And namespaces or what's that namespaces? Even I forgot. Namespaces in Kubernetes. Okay. Kubernetes supports multiple virtual clusters backend by the same physical cluster. These virtual clusters are called namespaces. The clusters are called namespaces. Virtual clusters are called namespaces. Assume that you can maintain multiple clusters by using Kubernetes on the same. It's like I told you, on these 3 physical nodes, you are maintaining one cluster, right? Similarly, you can maintain multiple clusters on the same physical nodes, or one cluster on these 2 nodes, other cluster on these 2 nodes, other cluster on these 3 nodes. You can form n number of clusters on n number of nodes by using Kubernetes master. All that you need to do is make sure that these nodes are connected to your Kubernetes master. No, that's what here the in detail terminology statements might help you. Cluster, the compute resource on top of which the containers are built, are nothing but clusters. Pods, a collocation group of Docker containers, are nothing but pods. Even in the pods, you can have one volume can be shared with different Dockers. It means that you can mount the same storage to different containers. Okay. Replication controllers manages the life cycle of pods. I told you, one pod goes down, I mean one container in the pod goes down or entire pod goes down, the replication controller will build a new one. Services like set of pods, they act on the basis of load balancers. Labels, again, you can virtual names given to the clusters with object based pattern called key is equal to value. Now, talking in detail about pods, what exactly this pods does is, pods are told you combination of containers. It means that logical or group of containers. They are ephemeral. When I say ephemeral, the word ephemeral, what it means they they are always they don't die. Ephemeral means they don't die. So I can say that containers are ephemeral on the pod, because if one container goes down, automatically Docker, Kubernetes master will launch another container. It means that they are ephemeral. Okay, and they can share the volumes, same storage with different containers. Assume that this ash color box is entire pod and you have 3 Docker containers. They can share the same storage. Okay, now and they're identical with them same labels, and they can communicate. Containers within the same pod can communicate with each other locally. Okay, but containers across different pods cannot communicate. This is something different. So now this is how we'll talk about one architecture. Now I took 3. Okay, I want to maximize this. I hope you cannot see it. Okay, now talking specifically about this diagram, this was something I did in my office. Like we launched one Kubernetes master, okay, and 2 minion nodes that are connected to Kubernetes master. Okay, now Kubernetes master will handle the minion nodes and it will create the cluster, and everything can be done on this master. Now for my Kubernetes master, I have one port Ethernet interface, okay, and that Ethernet interface is connected to all the different minion Ethernet interfaces so that they can communicate privately. Sorry, here it is not public, it is private. Now I have even public connections that is connected to the minions also. Why? Because when I say on Kubernetes master, hey, create a container MySQL. Now, what if this minion does not have the MySQL image on his local registry? It has to download from the internet, right? It has to connect to Docker Hub. For that, it uses this public network and it will connect to Docker Hub and it will download that MySQL image to his local registry. From that, it will launch a container. Always minion nodes require internet connection, because if it doesn't found the image locally, it has to download from the Docker Hub. All the images are maintained by Docker Hub, Docker community guys. Now this is something commands, how I install the master. Okay, how I install this minions, everything in detail, step by step. What are the configuration changes I did on that config files. This talks about all that configuration parts. After installing Kubernetes, you have to go to etc file and you have to create listen URLs and everything. Okay, if you are trying to launch Kubernetes master, install Kubernetes minions, this document will help you. Now This is about Kubernetes and everything. Any doubts on this topic? Now we do have a service on the cloud with AWS and GCP. As Kubernetes is a GCP's product, okay, and AWS is offering these containers with the help of a service name called ECS. ECS stands for EC2 Container Services. On the backend, what he is doing is he's launching instances. On that instances, he's installing Docker and he's creating containers on it. Okay, when it comes to GCP, he is offering that with a name called Google Container Engine, GKE. Sorry, Google Kubernetes Engine, not container. Okay, these are different service names of AWS and Google Cloud. They're offering this as a service to end users on cloud. Assume that you have one container running on with AWS. You want to move it to different cloud or on premises. Yeah, just bundle it, upload it to Docker Hub, bundle it, upload it to Docker Hub, and from the Docker Hub, here you can download it and you can. It means that containers can run across the platforms, either it is cloud with Amazon or cloud with Google or cloud with any other or local on-premises, your local machine, anywhere container can run. All you need to do is just have the Docker running, Docker daemon running on the machine. That's it. So any doubts guys you have on this topic?
No, Karthik.
Theoretically everybody is clear, I know, but practically you have to do it if you want to dig much deeper. That's it guys, that's it for today's class, and we'll meet up on Tuesday because we have a festival on Monday. Okay, in the meantime I'll share you all these videos to you, and this document also, Docker and Kubernetes document. Thank you. And Suraj, you just stay, we'll have a chat. Yeah, Suraj.
Yeah, Karthik, today, let me see.